Okay, welcome back. Today we're looking at sort of the last kind of special case here when dealing with trig. It's a sign law case, but it's called the ambiguous case because we end up with a couple of different possibilities. So we'll take a look at these. On the screen, you can see I've got a couple of rulers here just to show you that what I've got is an accurate diagram. I don't know how well you can see it, but down in the corner of the ruler, it's showing 30 degrees right there. And my measurements, I've got 6.1 right about here. I've got 3.6 right about there. Okay, so just sort of recognizing that what you see on the screen is accurate. I'm going to get rid of the rulers because they're just going to be in our way. But this isn't something that's been made up. Um, okay, so if I look at this diagram, when based on what we've seen before, I see I have two sides, I have an angle, and so when we consider going through the trig possibilities, there's no right angle triangle, so sine, cos, and tan in their primary as the primary ratios are out. It's not a side angle side, two sides with the angle between, and it's not three sides, so cosine law is out, which means I'm going to go ahead and solve it using regular sine law, using the regular sine law. If I do though, I end up missing something. Okay, so the key here is I'm having some trouble with the pad today. Give me a second. Get that out of the way. Grab that. If I flip this side left to right, hopefully what you can see is there is a possibility here to have the exact same measurements, the 36, the 61, and the 30 degrees, and have a different triangle than the one I had looked at originally, or that was on the screen originally. Okay, so it turns out that when we have this information specifically, two sides and the following angle, okay, so a little bit different obviously than the cosine law. I have to have the two sides in a row and then the angle that follows. I'm not going to be able to move this. Annoying. But essentially it's a line coming down this way instead. Um, when I have this side followed by a side followed by an angle, and this side of course down the bottom is just saying that's where the other side will end up being. There we go. I actually have two possibilities. I have, or at least I can, sorry, have two possibilities. I can have this green triangle on the outside, and I can have the red triangle right here. And so what we have to figure out is when is this going to be a situation that we have to consider. Okay, so on this next page, just kind of moving forward, I'm going to delete that, I guess. Um, if I had something quite different here, 360, for example, kind of extreme number, but if this side is quite long, I think you can see pretty clearly that it can't loop around underneath the way the other one did. So to keep if this side is extremely long, it's always possible, first of all, to draw the triangle, but you've no concern about it potentially having that same situation where one side is here and or here. So as long as the second side out here, the side across from the angle we know is big enough, there's no confusion. There is another possibility, and if that's that the side is quite small. Okay, so if this is 60, this might be, well, let's go extreme and say a side of 10. If somebody told you that the triangle we're looking at is 10, 61, and 30, I think you can see pretty clearly that this side can never reach, no matter how much I move it around, no matter how much I move it around, it can never reach the intended line down here. And so in this case, 10, 61, 30 is an impossible triangle. It doesn't exist. What does exist, of course, would be potentially a right angle triangle there, or again, the situation where I could have that same side here or here, given the information, and not know which one it is. It depends a great deal on that length specifically. So, to generalize, we might have an ambiguous case if, this is a if and only if, the IFF, we have side-side angle. Okay, so first thing is we have to have this pattern where I know that I have a side, another side, and the angle that follows. Okay, so it has to be a side, side, angle in order. Some people sometimes refer it the other direction because it's easy to remember. As a professional, side, side, angle is what we're looking at. And it says side 1 is less than side 2. Okay, so if we take them in order, then I suppose this would be side 1 of my side-side angle. This would be side 2 of my side-side angle. If this is smaller than this one, then we have potentially some problems. We could have, again, a situation where this side is just too small and the triangle doesn't exist. We could have the situation where the triangle is, or there are two possible solutions right here. And right here. And we could have the one solution where the side happens to be exactly forming the right angle triangle. Again, if side 1 is bigger than side 2, meaning the side is way out here somewhere, there's no issue. So it has to be that side 1, what we would refer to possibly as A, or what we will refer to as A for the sake of doing some calculations, A, B, and of course this is the angle A that we're actually interested in. So if A is bigger than B, there's no problem. But if A is smaller than B, or if side 2 is small, or sorry, side 1 is smaller than side 2, then we might have an issue. Okay, so side 1 is smaller than side 2, or A is smaller than B, then we have at least potential for a problem. And to figure out whether we are going to have a problem, or to find out what the solution to our problem is, we multiply B times sine A. Okay, so sort of looking back again, this value 61 times this value sine of 30. The way it turns out, and I intended to use 60 here exactly, but sine of 30 we've seen is 1/2, and so I kind of like using 30 for that reason. If this number is 30.5, if this number is 30.5, we end up with the hypotenuse. Anything that comes out a little bit smaller or bigger changes what our solution is. So when we multiply these values, if B sine A, yeah, sorry, I was misreading it. If B sine A is still bigger than the angle that we're looking at, then essentially what we're saying is what would be that opposite in the right angle triangle is bigger than the side that we have given to us, and so there's no solution. If B sine A is exactly equal to A, then that's the situation where we have the right angle triangle, we have the only one solution, and if B sine A is smaller than A, then we have two solutions. So I'm going to go through this one now and sort of look at it exactly as I would if this were a brand new problem for me and I didn't know whether there's one or two solutions. So the first thing I note, I have a side, I have a side, and I have an angle. So that is the potential ambiguous case. Now, my series of questions essentially that I'm going to ask myself. Question 1, is side A less than side B? If side A is not less than side B, then I don't have anything to worry about. So essentially, I'm going to go through these kind of in order to think about the fact that do I still have to consider the ambiguous case? Is side A 36 less than side B 61? Sure is. Okay, so again, this is A because it's opposite the angle A, and then this is B because it's just the other side. So A is less than B, yes. And so then basically I'm going to look at what is B sine A. What does that, again, mathematically work out to be? And as we already said, B is 61 times sine of 30, and that will give me 30.5. You can punch that in, obviously, if you're not sure. So I then have to compare B sine A to the other side A. And my various possibilities is B sine A, which is the 30.5, greater than A, equal to A, or less than A. And B sine A is 30.5, so I'm comparing 30.5 to the number 36, and so it's not greater than A, it's not equal to A, it is less than A. And so therefore, we're going to have two solutions. So those are the things that I have to look at to get to the point where I know, am I going to have the one or two solutions, or again, potentially zero solutions. Once I know that, then I'm going to go about solving the question. I'm going to pause the video for a second and start putting up part of the solution. Okay, so I've added a little bit in here. Didn't actually say initially, but let's assume that we're trying to find the missing side. So we've established there are two solutions. The first solution would be found doing exactly what you would have done on any kind of regular sine law question. We're looking to find the missing side. We can't yet find the missing side, so we established that we're looking for the angle theta here. Sine of theta over 61 is the same as sine of 30 over 36. Go about solving it. Theta is that. Solve it normally from there. I was actually going to leave it for you to do, but so if we just continue on, if theta is that value, then alpha, the third angle, can be found by subtracting from 180. It's 92.1, and then basically solve for the missing side. Okay. So that is the first solution, and it's exactly the one that you would have done if I hadn't mentioned the ambiguous case at all. Now what happens though, because the other possibility, and of course I can't do that, the other possibility is that I have a line coming this way instead. We recognize that nice red line maybe, or a blue line, or a green line. Let's make it a green line. So the second possibility is this one. I think you can sort of see that if we looked for the green alpha, let's call it, it's clearly not going to be the same as the original. And in fact, what it's going to be is 180 minus that original value. You want to understand that we're dealing with, since it's the sine law that we're working with, we want to make sure that we're getting the same value when we use the new angle as we would have with the old angle. And so if we think about the fact that in our cast law, all soup, or all students, or cast, however you want to remember that, sine is positive over here. So there are values over here that are identical to the values in this area. And so what's going to happen is, while we got about 57.9 as the one possibility, 180 minus 57.9 will give us the exact same numbers, and that ends up being the second angle, or the second possibility, I should say, for the angle theta. So the other possibility is that theta might be 180 minus 57.9. Which is 122.1. And now after that, we'll do the exact same solution as we had done over here. Okay, so if that's 122.1, then my alpha value will be 180 minus the 30 from the original, minus the 122.1 here. And I guess it's just trying to do this since 27.9. Sorry, a little messy there. And then basically just finishing up a sine of, oops, again, I should start with the, I should always start with the piece of information I want here. I'm looking for the missing side, so it's a little nicer if I do x over sine of 27.9 equal to 36 over sine of 30. And just in case you're wondering, I'm choosing 36 over sine of 30 because I want to. No reason why I could not use the other combination of the 122.1 and the 61 side as well. And then this, if I actually punch it in, will be approximately 33.7, whatever the units are. So that's essentially what we have to do when we have the two solutions. What ends up happening if you have a sort of a different one of the other two cases, maybe just clone this really quickly. We end up obviously not having to do as much work if there are not two solutions. And when we get to this point here, so assuming we didn't have a 36 here, let's assume the question gave us a, oh, okay, I can't actually get to it that easily, so we'll just sort of cross it off here. Let's say we, oh, it's good, this looks good, oh yeah. So we have the number 6 here. So when we do the same steps, potential ambiguity, is A less than B? A is definitely less than B, a lot less than B. 61 times sine 30 is 30.5, okay? And then we ask the questions, is B sine A, the 30.5, greater than, less than, or equal to the side that we're looking for? In this case, it is still greater than, and so therefore 0 solutions, and we're done. If we ended up with exactly 30.5, so the question said this is 30.5, when you go through it, you find that it's exactly equal, and therefore one solution, 90-degree angle, and you can solve it like a Pythagorean theorem if you choose to. So 30.5, 61, solve for the missing value, done. Okay, so the only one that really requires a significant amount of work at this point will be the second dimension. The second dimension, the second solution, the one with two solutions. Sorry, I should stop the video before I go and save it.